Number 3, I'm going to show you 2 ways because I saw a lot of people try to do it a way that I encouraged you not to do it in class, and it made it more difficult, but you could still do it. So I want to show you that way because you may already be halfway to the answer, but you couldn't quite finish it. I'm going to show you that way second. I'll show you the way I showed you in class first. So the first step here was to factor denominators. I cannot factor x plus 3, but I can factor x squared minus 9. So it's 3 over x plus 3 equals 9 over x plus 3, x minus 3. And if you factor this side, what you notice is that you actually have a factor in common here. So that's actually going to help us out. The second step was to figure out what I need to multiply both sides by. And remember, I'm just looking at my denominator to figure that out. So if I see an x plus 3 in my denominator, I'm going to put x plus 3. I'm going to do it on both sides. And then I see another x plus 3. So I don't have to put it again. And that's what people were missing if they didn't factor the denominator. And now I see an x minus 3, so I'm going to put an x minus 3 on both sides. So that's all I need on both sides, right? The next step was to actually treat this side like it's one problem, right? So what do you see that can cancel here? The x plus 3 and the x plus 3 can cancel. And then we're going to treat the right-hand side like it's a single problem. Make it one fraction. And over here, almost everything cancels. So all you're left with then is x minus 3 times 3 equals 9. This is all you have to solve. So you'll distribute 3x minus 9 equals 9. When you add this 9, these do not go away. This becomes a bigger number. Okay, you're just a couple steps away from the answer right there. So that's how I tried to get you to solve it in class. What some people were doing is they were not factoring the denominators. So they were just starting with the original problem here. And they were just from here saying, well, I see an x plus 3. And I see an x squared minus 9. Okay, and then they took this side, and they canceled, and they had x squared minus 9 times 3. And then they had this side, and they canceled, and they had 9x plus 3. Right, so you're not doing anything wrong, but what you've created is a much more difficult equation to solve. Because you created a quadratic. And to solve quadratics, we have to get it equal to 0, and then we're going to either factor or use the quadratic formula. So if I want to get this equal to 0, I'm going to move all of these terms to the left-hand side to be over here. So I'm going to subtract 9x, 3x squared minus 9x minus 27 equals 27. And when I subtract, a couple people were getting 0 here, but when you subtract negative 27 with another negative 27, you get negative 54. So now I have to factor this. I know, I'm not sure if you can see it or not, but there's a GCF here, so I'm actually going to pull a 3 out of everything. And that leaves a 3x here, and then 3 times 60 would be 20, so this is 3 times 18. And then if you factor this, you're going to get x minus, let's see, 18 is going to be 6 and 3. Need a negative 6 and a positive 3 to get a negative 3 here. So my answers here are x equals 6 and x equals negative 3. So I got 2 answers. Now, if you're careful though, if you look back and if you check this one, and you look at this, this is actually showing a domain restriction that x can't be negative 3. So that means that this one's extraneous. So you should have only reported that one as an answer. And you don't get this extraneous solution if you do it the way I showed you in class. If you do it this way, you're only going to get one answer, and you only get that one answer. So either way is fine. I've been trying to help you do it the easiest way so that hopefully you can remember it and you can finish it. Because some people got to about this step, and then they weren't sure what to do. And I can understand that. It's a much harder equation to solve. So if you factor the denominator first, that makes it much easier on this problem.